On question number 8, we have a repeated linear factor, and then if we try to factor this, we can't, and there's still an x squared there. So that's an irreducible quadratic factor. The numerator you never have to worry about factoring. So this is going to be equal to a over x minus 1 plus b over x minus 1 squared. And that is the repeated linear part. And then we need to add cx plus d over x squared plus 2. And that's the irreducible quadratic. So that is our template, and I need to multiply the entire thing by my original denominator. And start canceling things out. And I'm going to put the cx plus d in parentheses, and it's getting multiplied by x minus 1 squared. So there's a lot of simplifying on this one. If we FOIL this first one, it's going to be x cubed minus x squared plus 2x minus 2, all multiplied by a, then plus bx squared plus 2b. Then I want to FOIL the x minus 1 squared first to get x squared minus 2x plus 1. Okay, so we're doing good. There's going to be a lot of different terms on this one. Okay, so when you multiply a binomial times a trinomial, there's 6 different multiplications that you need to consider. So that's going to be cx cubed minus 2cx squared plus cx plus dx squared minus 2dx plus d. I almost ran out of room. Okay, so we need to group. We need to organize our terms here. So I have ax cubed plus cx cubed minus 2, or not 2, minus a x squared plus bx squared minus 2cx squared plus dx squared plus 2ax plus cx minus 2dx minus 2a plus 2b plus d. Okay, so after that we want to factor. So you want to factor the x cubes out, the x squareds out, and the x's out. So it'll be x cubed times a plus c plus x squared times negative a plus b minus 2c plus d plus x times 2a plus c minus 2d plus, I'll put the rest of them in parentheses, and then we can equate our coefficients. Okay, so I have a plus c is equal to 0 because there's no x cubed term on that side. So I'm going to jump to our next slide, and I have an x cubed equation. It's going to be a plus c is equal to 0. I want to jump back and look at the x squareds. All of this I'm going to set equal to the 10. So my x equation, or my x squared equation, is going to be negative a plus b minus 2c plus d is equal to 10. And then I'm going to set these equal to the 2. So my x equation is going to be 2a plus c minus 2d is equal to 2. And then what color should I use? Let's do orange. All the ones that didn't have an x, well, there's no constant on the left-hand side. So it's kind of like there's a 0. So the constant is going to be negative 2a plus 2b plus d is equal to 0. So this is a bigger matrix. So this will be a 4 by 5 matrix. And if you do RREF and convert to fraction, you get 14 over 3, 4, negative 14 over 3, and 4 over 3. So this will be 14 over 3, x minus 1, plus 4 times, or 4 over x minus 1 squared, plus negative 14 over 3x, plus 4 over 3, all over x squared plus 2. And then the other way to write it is if you move those denominators down to the main level. So that'll be 14 over 3 times x minus 1 plus 4 over x minus 1 squared plus, and then negative 14x plus 4 all over 3 times x squared plus 2. So this is the other form. So our time is at 10 minutes and 40 seconds, so this could be our longest problem. So good job making it all the way through this video. Don't forget to like, comment, and subscribe.